200 plus. Now, as most textbooks will do, yours included, they talk about the fact that there's static friction, there's a breaking point. As I apply a force to this table, the static friction is only going enough to keep it in place up until I reach some sort of point at which point it breaks, and then it's much easier for it to slide. In other words, the idea is that the friction drops. So if I plotted it, friction versus applied force. The friction is going to build and build and build until I hit a breaking point, at which point it suddenly lets loose and we have kinetic friction. So this is static friction and this is kinetic friction. If you'll notice here, my kinetic friction is a number. So if I know the normal force and I know the coefficient, I can calculate what the kinetic friction will be. The formula is F sub k is equal to mu sub k times the normal force.
So for us to, so basically what I'm understanding is things move because we build up friction and then it gets released after reaching a certain point, so it moves.
The way I picture it is, imagine the jigsaw puzzle.
Yeah.
So there's some interlocking going on there, and then once I break out of that, they're sort of writing on the surface, and it's much easier to write on the surface than it is if you're inside there. So once you can get it sort of popped out of the grooves, it's easier to flow. That seems to be the idea behind it. Static friction, if you'll notice, builds and builds and builds until you reach your breaking point. This right here is Fs max. That's the maximum static friction. So the formula is written as Fs is less than or equal to Usy. However, there's been some thought into this as people are looking at the several hundred-year-old equation and thinking, how much of a difference is there between mu sub k and mu sub s? It depends on what's really causing the friction. Is the friction caused because of sort of nooks and crannies, that there's just a bunch of little tiny normal forces preventing movement? Or is the friction caused because as the surfaces get closer together, there's more of an attraction between the two, between the molecules on the surfaces? And so if you have a really smooth surface, they can get even closer. So you get higher friction. Sometimes. So the idea behind that is that friction is really an attractive force between these two objects, and that if you plotted friction versus applied force, it actually is going to go like this and then level off. So this would be the kinetic friction or the maximum, which is the same as the maximum static. Now these are very clearly two different graphs, and it seems like it's easy enough to test which one you're going to get. I tried to find a couple years ago someone who's actually done this. I wanted to get the raw evidence. The only paper I could find was put out by a college senior, and the error bars were large enough that you really could not distinguish, which is the argument that this group generally makes, is that the mu k and mu s is found experimentally. There are large error bars there. It's not like they run 1,000 trials. So they get a value from mu k and mu s, and they go with it. Sometimes you get a range if you look it up on a table, and sometimes you get a number. So advocates of this claim, yeah, the book might say it's 0.3 and this is 0.4, but this might be 0.3 plus or minus 0.1 and 0.4 plus or minus 0.1. There's an overlap there, a large overlap. Most textbooks using that model. Some textbooks mention this and use that model. And there are a couple of textbooks that do this and they ignore that completely. This right now is sort of rare. in terms of how fast do physics textbooks change, there's an experiment in the 1890s talking about, basically it's considered to be the final evidence that ether does not exist in outer space. The idea was waves need some medium to travel through, light waves therefore need to travel through something to get to Earth, therefore the space must be filled with this thing called ether, as in ethereal. 1890s, textbook comes out, or the experiment's done that shows that ether waves do not exist. Ether does not exist. I have a book from 1950 which still talks about ether waves, even though the experiment was done more than a half century earlier. It just takes a while for physics textbooks to catch up. So it's quite possible your children will be doing taking physics, and they'll be doing this and not that. Or maybe they'll come up with something new.
So that was like a tangent
Yes.
that I wouldn't need to cool. Because most of the times I was trying to figure out if they were playing California Girls or not. They are.
Okay. The international fans will appreciate that.
Just wanted to let you know.
A number of years ago, they were installing new doors over in Ardmore, which is where we were doing physics mostly at that point. And throughout the class, as they were doing the drills, you'd be talking and then you get this throughout the entire class. That was more distracting, I found.
I mean, it is Katy Perry, so it's like kind of up there.
All right, so let's bring friction into it. I'm going to say that the static friction is 0.4 and the kinetic friction is 0.3. I will say that this initial speed is 0 meters per second. In other words, it starts at rest. So the question is, will it slide? And if it does slide, what will the acceleration be? So if we go back to our previous equation, this one right here, we have a formula, we have friction in the formula now, so we're just going to use this. I don't have to start back there and pop friction in again because we've already done that. So I'm going to take these two equations and we'll manipulate them. So I've got mg sine theta minus friction is equal to ma, and y equals mg cosine theta. All I did was just move that cosine theta over. The second substitution formula we'll do is for friction. So what I'm going to do is I got mg sine theta. So case 2, there is friction. We're going to check first to see with static friction. So I'm going to plug in the formula for maximum static. Minus mu sy equals ma. From the second equation, we now use that. We have a formula for y, so we plug that into here, and we have mg sine. So that's the substitution. We're now in the solving phase. I have these two equations. My unknowns are a and y. I'm going to take y from the second equation, plug it into the first equation, so I have mg sine theta minus mu s mg cosine theta equals ma. Do I have a common factor to every term?
M.
So I can divide out m, and I'm left with my acceleration formula for this problem would be g sine theta minus mu s g cosine theta. I have my formula for acceleration for this problem, and so I can now plug and chug. So this is going to be 10 times 0.6 minus 0.4 times 10 times 0.8. This would be 60 minus 32. Sorry, that'd be 6 minus 3.2. Which is 2.8. Is the block going to slide? Abigail?
Yes.
Therefore, static friction is not appropriate. So first, we did a check to see, is it going to move? It does move. Because it is moving, my static coefficient actually should be kinetic coefficient. And so what I'm gonna do is, I don't have to start over again, I can just now come into here where I have the mu sub s, put in mu sub k.
Question,
Yes?
where did the 0.6 and 0.8 come from?
My angle was 37 degrees, and the sine of 37 degrees is about 0.6, and the cosine is about 0.8.
Okay.
So I have A equals G sine theta minus mu sub k, G cosine theta. And so this will be 6 minus 0.3 times 8, 6 minus 2.4, which is 3.6 meters per second squared.
That's a 0.3 and 0.8 or 0.3 and 8?
That's point three, that's mu sub k, and then G's cosine theta is 8.
Okay.
Now, a quick check just to see if this makes any sense at all. When there was no friction, the acceleration was 6 meters per second squared, 6.0 something, roughly 6 meters per second squared. We add friction, the acceleration is less. Does that make any sense? It does to Gabrielle and Riley. Others, I hope so.
Wait, so both of those are our speeds?
Pardon?
So the 0.6 and the 2.8 are our
Accelerations.
Oh.
So
they're both
first, we see
accelerations.
if it's static. If it does move, then we have to use the kinetic. Now, what would this have looked like if it had not moved?
The acceleration would be 0. If it hadn't moved at all?
Most likely, it's not going to be 0. If it is 0, yes, it's just sitting there, acceleration 0, it's at rest, no acceleration, so it stays at rest. However, more realistically,
Negative?
yeah. If you've got a negative there, that means that I put a block on the ramp, positive is down, and I get a negative acceleration, means I put a block on the ramp and suddenly it starts moving upwards. That does not make physical sense. Remember that the static friction is enough to stop it, and we're assuming a maximum static. A negative means that we did not overcome the maximum static friction, so it did not start moving. Now, I can make the problem more convenient if I said, assume the mass moves and you skip that step. But this is, now we'll get into another one where, yeah, that'll save it for next week. The double ramp where you really don't know until you work through the math which way it's gonna slide, and that affects which way the friction's going. There was a step here. Stephanie is not part of this group. All right, so this is some of you. Oh, so I don't accidentally flash a grade.